Hello, welcome back. Let us now take a look at another high-level programming construct, the for loops. For loops are useful for iterating over a range of numbers. For example, you can sum all numbers from 0 to 9 inclusive. In the pseudocode, this is what it looks like. If ECX from 0 to 9, do this, and 4. What this means is that you use ECX as a counter. It will count from 0 to 9, and each time it counts, it starts off with 0 and then 1 and 2. So each time it counts, you take the value to add to the EX. So EX initially must be 0. So first time it enters the loop, EX is 0, 0 plus 0, assigned back to EX. So EX is 0. Then next time it loops, EX will increase to 1. And then it takes 1 plus 0 and assign it back to EX. So EX become 1. Then next loop, ECX will become 2. So 2 plus 1 becomes 3, assign it back to EX, and so on. So it keeps on doing that until it comes to the last condition where ECX is 9. And at line 9 will be the last number that is going to be added to EX. And then finally, when it comes to ECX becomes 10, then this condition is false and it will quit the loop. Now if you were to implement this in the assembly, this is what it looks like. So you move 0 to EX first to initialize it to initial value 0. EX is used as the accumulation to sum up the running total. ECX is for counting, so you're going to count from 0, so you enter the for loop. This for loop here is just a memory address, and when you enter it, you first take the ECX, add to EX, so 0 plus EX, and you get 0. The total is 0. Then you increment EX by 1, ECX become 1, then you compare whether ECX is 10. This is hex for 10. And if ECX is not yet 10, down here, jump not equal to 10, it will jump back to the memory address up here, which is a for loop. And then you add ECX to EX. And then you increment ECX by 1 again, then compare whether ECX is now 10. If it's still not 10, this jump not equal, meaning not equal to 10, so it goes back up to the for loop again. So it keeps on going like this until ECX becomes 10. Then when you compare, jump not equal is false, therefore it will not jump back up, it will quit the loop. So let's try now to implement this in our XDBG. So let's open our template file. And then let's key in this code here. Starting from here, we type, press spacebar, move EX 0, move ECX 0, add EX, ECX, inc ECX, compare ECX with hex 10, which is A, and then jump, press enter, and the next one is jump not equal to the for loop. So the for loop is actually this address here, which is the instruction add EX ECX, which is this address here. So we copy that one there, copy that address, and we put it down here, paste the address there. So now we are ready to run. So let's save this first, file patch, and we will call this 37 for loop .exe. Now we can open that file, for loop.exe, and run it. So first we put a breakpoint here, then we run to our breakpoint and we step over. It moves 0 to EX, step over, move 0 to ECX, step over, and now you see EX and ECX are both 0. Then we add ECX to EX and save the result in EX. Then we increment ECX by 1, so ECX become 1. We compare whether ECX is 10, it is not 10, so jump not equal to 10. So because it's not equal to 10, so you jump back up here and add. So it's going to add 1 to 0, which is ECX add to EX. So it's now going to add it, so step over. So now EX become 1, increment ECX, ECX become 2. Compare whether ECX is 10, no it is not, so it will jump up again. Now it's going to add 2 to EX, so EX now becomes 3, increment ECX, ECX becomes 3, compare whether ECX is 10, no, so you jump back up again, so you add 3 to 3, so that gives you 6 in EX. Increment ECX, ECX now becomes 4, step over, it is not 10 yet, so you go back up and add 4 to 6, so it gives you 10. So now you have 10 in EX, so the hex for 10 is A. Then increment ECX, ECX now becomes 5, and then compare whether ECX is 10, nope, so we jump up again, so we add ECX to A, so 5 plus A, and that will give you F in hex. F in X is hex for 15. So now increment ECX, ECX now becomes 6, compare whether it's 10, nope, so it jumps back up again and adds 6 to F, and that gives you 15 in hex, which is 21. Now let's go down, increment ECX by 1, ECX becomes 7, compare is ECX 10, no, so it jumps back up again and adds 7 to this 21 here, so it gives you 1C, which is 28. Continue going up, increment ECX, ECX becomes 8, compare ECX where it's 10, nope, so jump back up, add ECX to this hex 1C, so you get hex 24. Then continue, increment ECX by 1, ECX becomes 9, compare is ECX 10, no, so jump back up again, take this 9 add to hex 24, that will give you hex 2D, and then continue, increment ECX by 1, ECX is finally now 10. So now compare whether it's 10, yes, so because it is, this one is this jump will not happen, you see it is grayed out, so it continue to go straight. So you have finished your loop, and now the value in EX is 2D, and 2D is hex for 45. So you have just sum up all the numbers from 0 to 9, and you get hex 2D, which is 45. So this is how you can implement this is how you can implement loops using the high-level programming construct to understand the logic. So that's all for this video. Thank you for watching.